Hello, today I am going to walk through Section 4, Day 2, solving or graphing systems of inequalities. As you watch this video, it's going to be very important that you pause often along the way. You can't just work through it and continue to write as I speak because I won't be pausing a whole lot because you can pause the video. So what I'd like you to do actually is flip back a page. You should be right now on page 17, but I actually want to backtrack to yesterday. So I have page 16 here in front of me. This is the last example we worked yesterday. So today we're going to continue to work on systems, and then I'm going to just review a couple of concepts. So first of all, I want to review with you what we did on this last example. So when we do a system of inequalities, we graph both lines just like we normally did. So the first line here, y is greater than or equal to 2x, is the line that is solid. And then I shaded greater than. So I shaded kind of above and over to this side. Then I have a second line. Remember, y equals mx plus b. So I started at 1 right here. So you're looking at the dotted line. And then I went up 1 over 1, and that's this dotted line here. Shading is below. And so remember, yesterday we are looking for the double shaded area. That is the solution to our system. So we selected any two ordered pairs as long as they fell in the shaded region. Those are solutions. And then two ordered pairs that are anywhere on the outside of the shaded region, the double shaded region, would be not solutions. Okay? So that being said, let's go back to page 17. The first question is asking if 0, 0 is a solution. So is 0, 0 a solution to the linear system of inequalities? Well, in order to be a solution based on yesterday, it has to apply or fall within the double shaded region, which means that if I were to take these ordered pairs and substitute them back into the equation or the inequality, it would be a true statement. So I need to take 0, 0 and substitute it into both and see what I end up with. Now remember, I have x and y. So y is greater than 3. Well, notice there's no x value, so I'm only working with the y. So I'm going to plug in, is 0, I said greater than, it's less than. Is 0 less than 3? Well, we would ask ourselves that question. Yes, that is less than 3. So it works here, but I need to check it here. So I need to plug in 0 for y greater than 0 for x minus 2. So I need to do the math over here. 0 greater than 0 minus 2 is negative 2. Is 0 greater than negative 2? Yes, it is. So because both of them are yes, this is a solution to the entire system. So I'm going to write here, yes, a solution to the system. Okay. I have to have yes on both of them, so you must check them both. If one of them is a yes and the other is a no, then it is not a solution for the whole system. So let's try the second one. If you want to, you can pause the video and try the second one on your own and then resume the video to see if you agree with what I have. Is 1, 0 a solution to the system of linear inequalities? So remember x comma y. So let's plug it in. I'm going to plug in 0 for y less than or equal to x is 1 plus 1. So is 0 less than or equal to 2? Yes, 0 is less than or equal to 2. All right, and try the next one. Y is 0. Is 0 bigger than 3 times, plug in 1? Is 0 greater than 3? No, 0 is not greater than 3. So because I got a yes and a no, this no will make it fail for the whole system. So I'm going to say not a solution. Okay, so it must be yes and yes in order to be a solution. Okay, and that represents, if I have yes and yes, from a graphical perspective, I have selected an ordered pair within, if I were to graph it, my double shaded region. All right, and the rest of this is just a variety of questions throughout the unit. Which is the graph of x is less than or equal to negative 8? So some key elements. First of all, x compared to a number. Is it a horizontal line or a vertical line? And it is a vertical line. So I can get rid of choice A because it's not horizontal and choice B. Now remember, if you don't remember if it's horizontal or vertical, you can make a T-chart and X must always be -8. Y can be any number. So when you plot this, if I were to look at graph A, -8 is over here and 0 is right on the graph, and then 1 and then 2. So these are the correct lines. It's less than or equal, so I want a solid line. So I can eliminate D, and then my shading should match. It should be less than -8. So my answer is C. So it's really important on these types of problems that you do process of elimination as you check. Okay? All right, moving right along. The next one. Which of these four is the graph of y greater than -3/4 x plus 7? Now, as I look at my 4 lines, let's just make sure they look in the same spot, but let's check it. I should be at 7. 1, 2, 3, 4, 5, 6, 7. And I am at 7 on all of these, okay? And then is it going down 3/4? 1, 2, 3, 1, 2, 3, 4, yes. So I don't need to look at the line any further. Greater than. First of all, dotted or solid? Well, this should be dotted. So A is out of the question, and so is C. Now, is my shading up here or down here? You're shading in all the Y's greater than the line. So my Y's that are greater than are above it, so I want choice B. This would represent less than, but I need greater than. Okay. All right. We're going to finish off with 2 systems. So you are going to graph and shade and determine what the double shaded region is. So I'm going to do both of them. Feel free to pause the video and work ahead, and that way you can double check if you got it right. So number 1, I am going to graph this line, so I need to be at 3. And then I'm going to go down 2 over 1, down 2 over 1. And when I do a system, I am going to count until I run off the graph, because I don't want to pick the wrong ordered pair if I have to choose a solution. So since I went down and to the right, I'm going to reverse both up and to the left so I can see where my line is. I want a solid line, like that. Okay. And then I need to shade less than the line. So if this is my Y, my shading will be over here. Okay? Second line, start at -2 right there, and I'm going to go up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2, 1, 2. Now I'm going to go the other way, down 1 and over 2, down 1 over 2, over 2, over 2. I want a dotted line, so I'm going to add in between each dot these little dotted lines. And I need to shade greater than. So I need to shade on this side of my line. So my double shading is right here. And I'm going to color that in even darker once I find it, just to emphasize that. Okay, so your double shading should kind of be over here to the left. All right, if you got this one, I would encourage you to pause the video, try the second one, and then come back when you are done. Okay, number 2, graphing the first inequality. I'm going to start at 1, and then my slope is 1 over 1. So up 1 over 1, up 1 over 1. Okay, and then I can kind of go the other way. Okay. So I need to make a solid line because it's less than or equal. So my shading is less than. So that would represent everything down here on the Y. So it's going to be like that. Y greater than 2. Now there's no X value, so when it's just Y, it's a horizontal line. So I need to find 2 on the Y-axis, right there. And it's horizontal, so, and it is also dotted. So I'm going to come through here, and I'm going to make my dotted line. Okay. Now I need to shade Y is greater than. So I need to shade above the line. And so my double shading is on in this little triangular area right here. Okay? Now, if I were to pick a solution out, and it doesn't say to, but when you pick a solution, you choose an ordered pair out of the shaded area. So a solution on this one, I could maybe choose this one right here, and that is represented by 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5. So 7, 5 would be an appropriate solution. I could choose the origin on the first one. 0, 0 would work. Okay, so this is systems of inequalities. So I'd like you to, if you haven't finished these up, go ahead and finish these up, and then you're ready to move on to the next part of the lesson.